Hi everyone, in this video you're going to learn how to do arithmetic sequences. So the first thing we're going to go over is the definition of a sequence. So this one is just a very generalized definition. It's not really the definition of an arithmetic sequence. We'll go over that and we'll define it later on in the video. So first of all, what is a sequence, right? The sequence is just a set of numbers with a pattern. And every number in a sequence is known as a term. Just gonna make this a bit longer. So let's just go over what a first term is. It's actually pretty self-explanatory, but I see students get confused with this a lot. So the first term is the term that starts sequence. Okay, there we go. Now let's go over what a subsequent term is. So a subsequent term are the terms that follow the first term and follow a certain pattern, right? So basically how subsequent terms are denoted are with n. So basically n is the term number of the subsequent terms. And yeah, basically that is really all you need to know. The subsequent term is usually denoted as a subscript n. So let me just write that out so nobody gets confused. It's actually a really specific way of writing it. So it has to be a n. Notice how the n is below the a. You need to make sure that this happens because otherwise it's going to be inaccurate. And the first term is denoted as a 1. Again, a needs to be below, 1 needs to be below a, and not equal to a. So not a1, no, it has to be 1, a below 1. Like so. Okay. So, oops. So now let's get into actually looking at what an arithmetic sequence is, right? So an arithmetic sequence is just a sequence in which the term varies by a common difference or the same difference. So let's just look at an example. That's a lot of words to understand. So let's see. Okay, so the first thing we're going to go over is, let's just create a set, label it A, set A. And then we're going to make the terms 3, 6, 9, 15, 12, then 15, right? Sorry if this is really a terrible curly brace. I'm using a new tablet that I'm not really familiar with, so it's just taking a bit of time for my hand to get calibrated with it. Okay, so when in set A, what we can do is, let's see, let's look at what makes it an arithmetic series, right? Sequence. I apologize, not series, sequence. So basically, between 3 and 6, there's a common difference, right? There's like a difference between it. So what we define sequences is a set of numbers with a pattern, right? Pattern. So what is the pattern in this? Well, let's find out. So what is A1 in this sequence? A1 is known as the first term, remember? So A1 is 3. So from that, we can infer the remainder or the remaining term numbers in this. So this instance is 1, this would be 2, 3, 4, 5. And each term number can be denoted as A1, oh my gosh. Sorry, okay. Again, my tablet is giving me some problems. A2, A3, A4, oops. So on and so forth until AN, or the total number of terms, right? N is total number of terms. Okay, so now let's look at the difference between A1 and A2. So what is A2, right? So A2, let's check, is 6. So let's look at the difference, right? The difference is 6 minus 3, which is equal to 3. So we know that to get to 3 to 6, we need to add 3. Now let's look at how to get from A2, which is 6, to A3, which is 9, right? So let's look at the difference. 9 minus 6 is equal to 3. Hey, I think I'm starting to sense a pattern. To get to the next term, you need to add 3. Let's just check it one last time. So A3, which is 9, to get to A4, which is 12. Right? So let's check. This one is 12 minus 9, which is equal to 3. Hey, we found a pattern. So there, let's just write a rule for this. To get to AN, or the term you want to find, you have to add the previous term. So let's look at this, right? To get to A2, we had to add 3 to A1. To get to A3, we had to add 3 to A2, so on and so forth. So let's look at the term numbers for now, right? So A1 to A2. Let's say the term we were looking for, or AN, was 2, right? So to add one more, we would actually denote this as A and N minus 1, the position number minus 1, which is the previous term, plus 3, right? Okay, so this format is known as recursive formula. Basically, it's dependent on the previous term to find the next term. But looking very realistically, this isn't very efficient, right? having to find, say we had to find the 101st term. Imagine having to find the 100th term, then adding 3 to it. That seems like an impossible task. That's why we have something known as an explicit formula. Oops. Okay, see again, this tablet, I'm not very familiar with it, so my handwriting, please excuse my terrible handwriting. The explicit formula just is a generalized formula, which usually uses term numbers, right? So like A2, A3, A4, right? So let's just discover how to write a formula like this, right? So let's just use example 1 again. Let's see. So let's see what we have to add to term 1. Let's just focus on A1, right? Which is 3. We know that to get to A2, we had to do A1 plus 3. But say we had to get to A3. We know that we have A1 or 3 plus X. Oops. What? Is equal to, let's see, A3, right? Which was 9. So using some basic algebra, we know that X is equal to 6. So we can rewrite this as 6. But we also know that the term is increasing by 3. So we can rewrite 6 as 2 times 3, right? So let's just rewrite this as A1 plus 2 times 3. And we can rewrite the first equation as A1 plus 1 times 3. Now let's look at A4, right? So in order to get from A1 to A4, we needed to add 9 to get to 12. So let's rewrite this as A1 times 3 times 3. Hey, I think I'm sensing a pattern here, right? So the coefficient of 3, we know that these coefficients are being multiplied by 3. But I think I see a pattern here. So look at the term numbers over here, right? So A2, A3, A4. I noticed that the coefficient is n minus 1, or the term number minus 1 is equal to the coefficient here. See, let me just rewrite that closer to the term so that you'll be able to see it better. I'm going to use a different color. Okay. Notice how here your term number is 2. Oh, that is not good. There you go. So 2 minus 1 is equal to 1. That's the coefficient, right? Then 3 minus 1 is equal to 2. This is the coefficient. Then finally, 4 minus 1 is equal to 3. Hey, pattern? I think not. So let's generalize this a bit, right? So let's see. We know that from this example, there is a number that is being multiplied by another number, adding to the first term. So, and we also found that there was a relationship between the term number and like subtracting 1 and multiplying it by the same number, right? So let's just put some words to this to make it clear. So we have the number 3 here. We know that in order to get to the next term, we had to constantly add 3. So we're going to label 3 as our common difference. This works for all arithmetic. Make sure you understand this. Arithmetic only. So, okay, for arithmetic, you have, great. Again, my tablet is acting up. I'm sorry, guys. Common difference. And usually this common difference is denoted or is assigned the variable of D. So then we know that we have a term number, right? So that's defined as N. Then we have A1, which is the first term of a sequence. Then we have, actually, yeah, I think we're ready to write our formula. So what we can write here is I'm just going to write everything we've discovered in one formula. AN, or the term we want to find, is equal to the first term, A1, plus the term we want to find, or AN. Oops, let me just undo that. The term we want to find, the term number that we want to find, because that's what we saw here, right? That one basically showed us that the term number -1 gave us the coefficient that we wanted to multiply by our common difference. So let me just write the common difference in here, D. And we see that it's 2 minus 1, 3 minus 1. So the term number, or N minus 1, right? So this is our explicit formula for an arithmetic sequence in general. So let's make it specific to set A, right? So we know that in order to find the next term in set A, it's equal to 3 plus n minus 1 times the common difference, which we found was 3, right? Because we had to add 3 every time, add 3, so on and so forth. So now let's look at, remember how I made a joke that it would be impossible to find the 101st term with the recursive formula? Well, let's try finding the term with the explicit formula. Actually, let me just rewrite this AN because I told you guys not to do it and then I did it myself. Not a very good thing. Okay, so AN subscript. Okay, there we go. So we now need to find the 101st term, right? 101. And we know that is equal to 3 plus 101. Oops. We're going to pretend that never happened. Okay. And multiply this by, oh, great. Okay. Multiply this by 3. Oh, wait, I wrote the formula wrong. Can someone spot what I did wrong? I know what I did wrong. So basically, remember when substituting in n minus 1, I actually had to do 101 minus 1. I just wrote 101, but actually it wouldn't make a difference because I'm adding 3 anyways. And it just so coincidentally happened that my common difference was the same as my first term, but really it usually wouldn't happen like that. So, but still, to show you guys how it works, let's see, 101 minus 1 times 3. So we have 3 plus 100 times 3, which is 3 plus 300, which is equal to 303. So the value of 101 is 303. So in other words, the 101st term of set A would be 303. Okay, so this video was mainly just a derivation of the formula an is equal to a1 plus n minus 1 times b. In the next video, we're going to look at ways to modify it, tweak it, and use it to the way we want to find a term which is not related to the first term or some things like that, right? And also, I'd like to add that I've created a note sheet for this. I will also link an image of this in the document if you want to refer to it. But yeah, thank you so much for watching this video, and I hope this helped. If you have any suggestions, as always, please do comment it down in the comments below, and I'll be sure to implement them to my best ability. Thank you so much. Bye.